Codes and Relationships, UGC NET JRF Environmental Science Paper I Lecture. Codes and relationships are important reasoning topics frequently featured in competitive exams like UGC NET JRF. These problems assess a candidate's ability to decipher and apply rules or logic based on the relationship between numbers, letters, or symbols. This lecture covers the fundamentals of codes and relationships, various types of problems, techniques for solving them, and previous year questions. 1. Definition of codes. A code is a system of rules used to represent information in a hidden or compressed format. Codes typically involve numbers, letters, or symbols that follow specific patterns. The objective in code-related problems is to decode or decipher the hidden information by recognizing the pattern or rule. 2. Types of codes. Alphabetical code. In alphabetical coding, letters of the alphabet are converted into corresponding numbers or symbols based on a fixed rule. The most common examples are the direct alphabetical order, reverse order, or shifting by a fixed number. Example: A equals 1, B equals 2, C equals 3, and so on. Number code. In number coding, numbers are substituted for letters, where each number corresponds to a particular letter, often based on their position in the alphabet or other mathematical rules. Example: 1 right pointing arrow A, 2 right pointing arrow B, 3 right pointing arrow C, and so on. Symbolic code. In symbolic coding, symbols such as hash, et, or other characters replace letters or numbers. These symbols are assigned specific meanings, and solving the code requires recognizing the pattern of symbols. Mixed code. This involves using a combination of letters, numbers, and symbols in the coding system. Solving such codes requires careful attention to the rule governing the sequence. 3. Techniques for solving code problems. Identify the pattern. The first step in solving code problems is to identify the pattern in a series. The pattern could involve a simple shift, a direct numerical conversion, a reverse order, or a more complex mathematical or alphabetical relationship. Use of simple arithmetic operations. Some codes involve simple arithmetic operations such as addition, subtraction, multiplication, or division. In these cases, it's important to apply the correct operation to decipher the code. Shifting the letters. Many letter coding problems involve shifting letters by a fixed number of places in the alphabet. For example, if A is coded as D, the rule might be a forward shift of 3 positions. Checking for reverse order. In some problems, the code may involve a reverse sequence of letters: Z equals 1, Y equals 2, etc. This is commonly used in decoding alphabetic sequences. Trial and error. In some cases, applying trial and error with different patterns or rules can help in solving the code. 4. Types of code problems. Letter to number code. In this type of problem, each letter is converted into a number based on its position in the alphabet. Example: A equals 1, B equals 2, C equals 3, D equals 4, and so on. What is the code for the word cat? The code would be C equals 3, A equals 1, T equals 20. Therefore, the code for cat is 3120. Number to letter code. Here, a number is converted into a corresponding letter. Example: 1 right pointing arrow A, 2 right pointing arrow B, 3 right pointing arrow C, 4 right pointing arrow D, and so on. What is the letter code for the number 15? The letter is O, 15th letter in the alphabet. Substitution code. This involves substituting one letter or number for another according to a fixed pattern. Example: A equals Z, B equals Y, C equals X, D equals W, and so on. What is the code for the word hello? Using this reverse substitution, we get H equals S, E equals V, L equals O, L equals O, O equals L. Therefore, the code for hello is SVOOL. Shift code. In shift codes, each letter is shifted by a certain number of places in the alphabet. Example: A equals 1, B equals 2, C equals 3, and so on. If the rule is to shift each letter by 3 places forward, what will be the code for the word key? K right pointing arrow N, E right pointing arrow H, Y right pointing arrow B. Therefore, the code for key will be NHB. Mixed code with arithmetic operations. In cases, the code involves applying arithmetic operations, addition, subtraction, to the position of letters. Example: If A equals 1, B equals 2, C equals 3, and so on, and we add 2 to each number in the word map, the corresponding code would be M right pointing arrow O, A right pointing arrow C, P right pointing arrow R. So, the code for map is OCR. 5. Relationship problems. In relationship problems, candidates are required to identify the logical or familial relationship between different individuals or entities. The task usually involves interpreting complex relationships from the given data. Blood relations. This involves interpreting family relationships based on the description of a family tree. Example: A man is married to a woman, and they have 2 children. One child is the brother of the other child, and the mother of one child is the daughter-in-law of the man's father. The question may ask you to identify the relationship of the second child to the man. Directions and distances. Problems related to directions involve determining the relative position of a person or object based on the given direction and distance. Example: A person walks 10 meters north, then 5 meters east. What is the straight line distance between the starting and ending points? Coding and decoding of relations. This type of problem involves identifying the code based on relationships. The code may represent the family tree, positions, or any other relevant relationship. 6. Solving relationship problems. Step-by-step approach. Identify the type of relationship. First, identify whether the problem deals with direct relationships, e.g., father-son, mother-daughter, or indirect relationships, e.g., cousin-nephew. Analyze the information. Carefully read and break down the information provided in the question. If necessary, draw diagrams or family trees to visualize relationships. Use logical reasoning. Use logical reasoning to deduce the correct relationship. Eliminate irrelevant information and focus on the key details. Apply general relationship rules. Standard relationship rules like brother of the mother, means, uncle, can be helpful in solving these types of problems. 7. Previous year UGC NET questions on codes and relationships. Which of the following is the code for the word paper? A. 161-16518. B. 161-18518. C. 162-16518. D. 161-18165. Answer: 8161-16518. UGC NET 2021. In a certain code, family is written as GNBMJZ. How is circle written in that code? A. DJSMD. B. DJSMFC DHSMED DJSNF. Answer: a DJSMD UGC-NET 2020. If in a code language, computer, is written as DPQVSUFS, what will be the code for science? A. TDJFODF. B. TDFJOFHC TDFJOFGD TDFJOFI. Answer: C. TDFJOFG UGC-NET 2019. In a certain code, logical is written as MPHJDMB. What is the code for process? A. QSTFDTU. B. QSFTUQC QSFETRUD QSTFETU. Answer: A. QSTFDTU UGC-NET 2018. If the word great is written as HFSVU, how is whole written? A. XIPMF. B. XHJMFC XHILD XIPME. Answer: A. XIPMF UGC-NET 2021. Conclusion. Code and relationship problems are an integral part of reasoning in competitive exams like UGC-NET JRF. By understanding the different types of codes and relationships and practicing regularly, candidates can enhance their ability to solve these problems quickly and accurately. Let me know if you'd like more practice problems or detailed explanations on any particular type. You said. Mathematical aptitude fraction ChatGPT said. Mathematical aptitude, fractions, UGC-NET JRF Environmental Science Paper I lecture. Fractions are a fundamental concept in mathematics, and they are frequently tested in competitive exams like UGC-NET JRF. A fraction represents a part of a whole, and understanding its types, operations, and applications is essential for solving a variety of mathematical problems. This lecture focuses on fractions, including their types, operations, and problem-solving strategies, along with relevant previous year questions to help prepare for the exam. 1. Definition of a fraction. A fraction is a way of representing a part of a whole or, more generally, any number of equal parts. It consists of two numbers. Numerator, the number above the fraction bar or slash representing the number of parts being considered. Denominator, the number below the fraction bar, representing the total number of equal parts. The general form of a fraction is ABBA, where A is the numerator, B is the denominator. 2. Types of fractions. Proper fraction. A fraction where the numerator is smaller than the denominator. Example: 3. 443, 7887. Improper fraction. A fraction where the numerator is greater than or equal to the denominator. Example: 5. 335, 9449. Mixed fraction. A combination of a whole number and a proper fraction. Example: 2. 14241, 357375. Equivalent fractions. Fractions that represent the same value but have different numerators and denominators. Example: 1. 2 equals 2, 4 equals 4, 8, 2, 1 equals 4, 2 equals 8, 4. Like fractions. Fractions that have the same denominator. Example: 3. 553, 2552. Unlike fractions. Fractions that have different denominators. Example: 2. 332, 1441. 3. Operations on fractions. Addition and subtraction of fractions. Like fractions, if the fractions have the same denominator, add or subtract the numerators and keep the denominator the same. AB plus CB equals A plus CBB. A plus BC equals BA plus C. AB minus CB equals A minus CBB. A minus BC equals BA minus C. Unlike fractions, to add or subtract fractions with different denominators, first find the LCM, least common multiple, of the denominators, then adjust the numerators accordingly. Example: 2. 3 plus 1, 4, 3, 2 plus 4, 1. Find the LCM of 3 and 4, which is 12. Rewrite the fractions as 8. 1, 2, 1, 2, 8. And 3. 1, 2, 1, 2, 3. Add the numerators: 8. 12 plus 3, 12 equals 1, 1, 1, 2, 1, 2, 8 plus 12, 3 equals 12, 11. Multiplication of fractions. Multiply the numerators together and the denominators together. AB times CD equals A times CB times DB. A times DC equals B times DA times C. Example: 2. 5 times 3, 7 equals 6. 3, 5, 5, 2 times 7, 3 equals 35, 6. Division of fractions. To divide by fraction, multiply by its reciprocal, invert the second fraction and then multiply. AB divided by CD equals AB times DC equals A times DB times CBA divided by DC equals BA times CD equals B times CA times D. Example: 2. 5 divided by 3, 7 equals 2. 5 times 7, 3 equals 1, 4. 1, 5, 5, 2 divided by 7, 3 equals 5. 2 times 3, 7 equals 15, 14. Simplification of fractions. To simplify a fraction, divide both the numerator and denominator by their greatest common divisor, GCD. Example: simplify 12. 181812. The GCD of 12 and 18 is 6. Divide both by 6, 12. 18 equals 2, 3, 18, 12 equals 3, 2. 4. Conversion of fractions. Fraction to decimal. To convert a fraction to a decimal, divide the numerator by the denominator. Example: 3. 4 equals 0.754. 3 equals 0.75. Decimal to fraction. To convert a decimal to a fraction, write the decimal as a fraction with the appropriate power of 10 in the denominator and then simplify. Example: 0.75 equals 75,100 equals 34. 0.75 equals 175 equals 43. Mixed fraction to improper fraction. To convert a mixed fraction to an improper fraction, multiply the whole number by the denominator and add the numerator. Example: 2. 1, 4 equals 2 times 4 plus 1, 4 equals 9. 4, 2, 4, 1 equals 4. 2 times 4 plus 1 equals 4, 9. Improper fraction to mixed fraction. To convert an improper fraction to a mixed fraction, divide the numerator by the denominator to find the whole number part and the remainder becomes the numerator. Example: 9. 4 equals 2, 1, 4, 4, 9 equals 2, 4, 1. 5. Applications of fractions. Fractions are used in various real-life scenarios such as sharing quantities, dividing a pizza, cake, or any other divisible object into equal parts. Statistics and data representation. Fractions are often used to represent parts of a whole in statistics. Finance and economics. Fractions are essential for calculating interest rates, investment shares, etc. Measurement. Fractions help in representing measurements like 1/2 kilogram, 3/4 liter, etc. 6. Previous year UGC net questions on fractions. Which of the following fractions is in its simplest form? A. 6886. B. 91212 C. 15252515. D. 7997. Answer. D. 7997. UGC NET 2021. What is the result of 3? 4 plus 2, 5, 4, 3 plus 5, 2. A. 23202023. B. 7997. C. 31202031. D. 8998. Answer. A. 23. 202023. UGC NET 2020. Convert 7. 887. To a decimal. A. 0.875B, 0.75C, 1.25D, 0.7. Answer. A. 0.875 UGC NET 2019. If a fraction is 4. 554. What is the equivalent decimal? A. 0.4. B. 0.8C, 1.4D, 1.2. Answer. B. 0.8 UGC NET 2018. Simplify 24. 363624. A. 2332. B. 3443. C. 4664. D. 2442. Answer. A. 2. 332. UGC NET 2017. Conclusion. Understanding fractions and mastering operations on fractions is crucial for mathematical aptitude in exams like UGC NET JRF. By practicing various operations, simplifications, and conversions, you will enhance your problem-solving skills. The key to success in fraction-related problems lies in regular practice and understanding the underlying concepts thoroughly. Let me know if you'd like more examples or further explanations on any part of fractions. You said, time and distance, ChatGPT said. Mathematical aptitude, time and distance, UGC NET JRF Environmental Science Paper I Lecture. Time and distance is a fundamental topic in mathematical reasoning, often appearing in competitive exams such as the UGC NET JRF. Problems related to time and distance typically involve concepts like speed, time, and relative motion, and they require an understanding of how these variables interact. This lecture will cover the essential aspects of time and distance problems, focusing on key concepts, formulas, and problem-solving strategies, along with relevant previous year questions to assist in your exam preparation. 1. Basic concept of time and distance. Time and distance problems typically involve understanding how distance, speed, and time relate to one another. The key relationship is speed equals distance times speed equals time distance, where speed is the rate at which an object moves in units like kilometer per hour, meter per second, etc. Distance is the total length traveled by an object. Time is the duration of travel. The formula can be rearranged to solve for distance or time. Distance equals speed times time. Distance equals speed times time equals distance speed time equals speed distance. 2. Types of speed. Uniform speed. When an object travels equal distances in equal intervals of time, it is said to be moving at a uniform speed. Example, a car moving at a constant speed of 60 km per hour. Variable speed. When the speed of an object changes during the course of its motion, it is moving at a variable speed. Example, a car accelerating and decelerating while driving on a highway. 3. Relative speed. Relative speed is the speed of one object in relation to another. It is an important concept when two objects are moving towards or away from each other. When two objects move towards each other, their relative speed is the sum of their individual speeds. Example, if one car moves at 40 km per hour towards another car moving at 60 km per hour, their relative speed is 40. Plus 60 equals 100. 40 plus 60 equals 100 km per hour. When two objects move in the same direction, their relative speed is the difference between their speeds. Example, if one car moves at 80 km per hour and another moves at 60 km per hour in the same direction, their relative speed is 80. Minus 60 equals 20. 80 minus 60 equals 20 km per hour. 4. Formulas for time, speed, and distance problem. Speed, distance, and time. Speed equals distance time. Distance equals speed times time. Time equals distance speed. Relative speed. When moving towards each other. Relative speed equals speed of A plus speed of B. Relative speed equals speed of A plus speed of B when moving in the same direction. Relative speed equals divides speed of A minus speed of B divides. Relative speed equals divides speed of A minus speed of B divides upstream and downstream problems. When a boat or object moves in a stream or river, the effective speed of the object changes depending on the direction it is moving relative to the current. Downstream speed. Speed downstream equals speed of boat plus speed of stream. Speed downstream equals speed of boat plus speed of stream. Upstream speed. Speed upstream equals speed of boat minus speed of stream. Speed upstream equals speed of boat minus speed of stream. Time taken to cover a distance. If the object speed is constant and time is given, use the formula. Time equals distance speed. Time equals speed distance. 5. Solving problems involving time and distance. To solve time and distance problems efficiently, follow these steps. Identify known and unknown quantities. Recognize the given values speed, distance, time, and what you need to find. Use the appropriate formula. Depending on the problem, use the formulas for time, speed, and distance or relative speed. Units. Ensure that all units are consistent, e.g., kilometer per hour for speed, hours for time, and kilometers for distance. Break down complex problems. If the problem involves multiple stages, e.g., different speeds in different parts of a journey, break it into smaller parts and solve each one. 6. Previous year UGC net questions on time and distance. A car moves at a speed of 60 km per hour. How much time will it take to cover a distance of 180 km? A. 3 hours. B. 4 hours. C. 5 hours. D. 6 hours. Answer. B. 3 hours. Explanation. Time equals distance speed equals 180 60 equals 3 hours. Time equals speed distance equals 60,180 equals 3 hours. UGC NET 2020. Two trains are moving in opposite directions at speeds of 80 km per hour and 100 km per hour. If they are 500 km apart, how long will it take for them to meet? A. 2 hours. B. 3 hours. C. 4 hours. D. 5 hours. Answer. B. 3 hours. Explanation. Relative speed equals 80 plus 100 equals 180. 80 plus 100 equals 180 km per hour. Time equals 500,180 equals 2.78180500 equals 2.78 hours, approximately 3 hours. UGC NET 2019. A boat can travel 24 kilometers upstream in 6 hours. The same boat can travel 30 kilometers downstream in 5 hours. Find the speed of the boat in still water and the speed of the stream. A. 6 kilometers per hour, 2 kilometers per hour. B. 7 kilometers per hour, 3 kilometers per hour. C. 8 kilometers per hour, 4 kilometers per hour. D. 10 kilometers per hour, 5 kilometers per hour. Answer. A. 6 kilometers per hour, 2 kilometers per hour. Explanation. Let the speed of the boat in still water be b. B kilometer per hour and the speed of the stream be s. S kilometer per hour. Using the formulas for upstream and downstream. Upstream speed equals b minus s. Downstream speed equals b plus s. Upstream speed equals b minus s. Downstream speed equals b plus s. Solve a system of equations to get the values of b and ss. UGC NET 2018. A cyclist covers 36 kilometers in 1.5 hours. What is his average speed? A. 22.5 kilometers per hour. B. 24 kilometers per hour. C. 25 kilometers per hour. D. 30 kilometers per hour. Answer. B. 24 kilometers per hour. Explanation. Average speed equals total distance total time equals 36 1.5 equals 24 kilometer per hour. Average speed equals total time total distance equals 1.536 equals 24 kilometers per hour. UGC NET 2017. Two vehicles start from the same point and travel in the same direction. One travels at 40 kilometers per hour and the other at 60 kilometers per hour. After how much time will the second vehicle overtake the first if they start at the same time? A. 1 hour. B. 1.5 hours. C. 2 hours. D. 3 hours. Answer. A. 1 hour. Explanation. Relative speed equals 60 minus 40 equals 20. 60 minus 40 equals 20 kilometers per hour. Time equals 0 km 20 kilometer per hour equals 1. 20 kilometers per hour 0 kilometers equals 1 hour. UGC NET 2016. 7. Conclusion. Mastering the concepts of time and distance, including relative speed and upstream, downstream problems, is crucial for solving problems efficiently in competitive exams like UGC NET JRF. The key to excelling in this topic lies in understanding the basic formulas, breaking down complex problems, and consistent practice. Make sure to practice regularly, focusing on both theoretical understanding and problem-solving skills, to improve your speed and accuracy in the exam. You said, ratio, ChatGPT said. Mathematical aptitude, ratio, UGC NET JRF environmental science paper I lecture. The concept of ratio is an important part of mathematical aptitude and reasoning, commonly tested in exams like UGC NET JRF. Understanding ratios and how to apply them is essential for solving problems related to proportion, comparison of quantities, and other real-world applications. This lecture will cover the basic concepts of ratios, types of ratios, methods of solving ratio problems, and strategies to approach related questions in the UGC NET JRF exam, including relevant previous year questions. 1. Definition of ratio. A ratio is a mathematical relationship between two numbers that shows how many times the first number contains the second. It is expressed as a fraction or with a colon. For example, the ratio of 2 to 5 can be written as 2, 5 or 2, 5. 2, 5 or 5. 2. The first term 2 in this case is called the antecedent, and the second term 5 is called the consequent. 2. Basic properties of ratios. Equality of ratios. Two ratios are equal if their cross products are equal. For example, the ratio A. B equals C dB A equals DC is true if and only if A times D equals B times C. A times D equals B times C. Simplification of ratios. Ratios can be simplified by dividing both terms by their greatest common divisor, GCD. Example. 8 12 equals 2 3. Divide both terms by 4, the GCD of 8 and 12. 12 8 equals 3 2. Divide both terms by 4, the GCD of 8 and 12. Proportions. A proportion is an equation that expresses the equality of two ratios. If A, B equals C dB A equals DC, then A, B, C, A, B, C, and D are said to be in proportion. 3. Types of ratios. Simple ratio. This is the basic form of ratio where two numbers are compared, such as 3, 4, 3, 4. Compound ratio. This is the ratio obtained by multiplying the terms of two or more ratios. Example. If 2, 3 and 4, 5. Then the compound ratio is 2 times 4, 3 times 5 equals 8 15. If 2, 3 and 4, 5, then the compound ratio is 2 times 4, set face, 3 times 5 equals 8 15. Inversely proportional ratios. When one quantity increases, the other decreases, and vice versa, the quantities are said to be in inverse proportion. Example, if x and y are inversely proportional, then x times y equals k. X times y equals k, where k is a constant. 4. Solving ratio problems. Ratio problems can be solved using various techniques, depending on the nature of the problem. Here are some steps commonly used. Direct proportion. If two quantities are directly proportional, the ratio of one quantity to another remains constant. Use the formula. AB equals CD. Cross-multiply to find the unknown. BA equals DC. Cross-multiply to find the unknown. Inverse proportion. If two quantities are inversely proportional, the product of the two quantities is constant. Use the formula. X times Y equals K. X times Y equals K. Algebraic method. For more complex ratio problems, algebra can be used. Assign variables to the unknowns, express the ratio in terms of these variables, and solve the resulting equations. 5. Applications of ratios. Ratios are applied in various contexts, such as mixing problems. When two or more substances are mixed in a given ratio, the final amount of each substance is determined by the ratio. Example, if a mixture of 30 liters is made by mixing water and alcohol in the ratio 3:2, the amounts of each can be calculated. Work and time problems. In work problems, the ratio of work done by different people or machines can be used to find the total work or the time taken. Example, if two workers in B can complete a task in 4 and 6 hours respectively, their rates of work are in the ratio 4:6, which simplifies to 2:3. Cost price and selling price. Ratios are used to calculate profit or loss in commerce, with the ratio of cost price to selling price determining the gain or loss percentage. 6. Previous year UGC net questions on ratio. If the ratio of the ages of A and B is 4, 5 and the sum of their ages is 72 years, what is the age of A? A. 28 years. B. 30 years. C. 32 years. D. 36 years. Answer. B. 30 years. Explanation. Let the ages of A and B be 4. X. 4x and 5. X. 5x respectively. 4x plus 5x equals 72 rightwards double arrow 9x equals 72 rightwards double arrow x equals 8. 4x plus 5x equals 72 rightwards double arrow 9x equals 72 rightwards double arrow x equals 8. Therefore, the age of A is 4. X equals 4 times 8 equals 30. 4x equals 4 times 8 equals 30 years. UGC NET 2020. The ratio of the lengths of two sides of a rectangle is 5:8. If the perimeter of the rectangle is 130 centimeters, what is the length of the longer side? A. 40 centimeters. B. 50 centimeters. C. 60 centimeters. D. 65 centimeters. Answer. B. 50 centimeters. Explanation. Let the sides of the rectangle be 5. X. 5x and 8. X 8x. The perimeter of a rectangle is 2 times L plus B. 2 times L plus B, so 2 times 5x plus 8x equals 130 rightwards double arrow 2 times 13x equals 130 rightwards double arrow 26x equals 130 rightwards double arrow x equals 5. 2 times 5x plus 8x equals 130 rightwards double arrow 2 times 13x equals 130 rightwards double arrow 26x equals 130 rightwards double arrow x equals 5. Therefore, the length of the longer side is 8. X equals 8 times 5 equals 40. 8x equals 8 times 5 equals 40 centimeters. UGC NET 2019. A person invests in two schemes and B in the ratio of 3:4. If the total investment is 35,000 rupees, how much is invested in scheme A? A. 12,500 rupees. B. 14,000 rupees. C. 15,000 rupees. D. 16,500 rupees. Answer. B. 14,000 rupees. Explanation. The total parts in the ratio are 3 plus 4 equals 7. 3 plus 4 equals 7. The amount invested in scheme A is 3. 7 times 35,000 equals 15,000 rupees. 7 3 times 35,000 equals 15,000 rupees. UGC NET 2018. In a class of 40 students, the ratio of boys to girls is 3:5. How many boys are there in the class? A. 10. B. 12. C. 15. D. 18. Answer. B. 12. Explanation. The total parts in the ratio are 3 plus 5 equals 8. 3 plus 5 equals 8. The number of boys is 3. 8 times 40 equals 1583. Times 40 equals 15. UGC NET 2017. A person divides 1,200 rupees between A and B in the ratio of 5:7. How much does A receive? A. 500 rupees. B. 600 rupees. C. 700 rupees. D. 800 rupees. Answer. B. 600 rupees. Explanation. The total parts in the ratio are 5 plus 7 equals 12. 5 plus 7 equals 12. The amount received by A is 5. 12 times 1,200 equals 600 rupees. 12 5 times 1,200 equals 600 rupees. UGC NET 2016. 7. Conclusion. Understanding the concept of ratios is essential for solving problems in competitive exams like UGC NET JRF. The key to mastering ratio problems lies in recognizing patterns, simplifying ratios, and applying the correct formulas based on the problem context. Regular practice of these types of questions will help you efficiently solve ratio-related problems in exams and improve your overall problem-solving skills. You said, proportion. ChatGPT said. Mathematical aptitude, proportion, UGC NET JRF Environmental Science Paper I Lecture. Proportion is a fundamental concept in mathematical reasoning that is closely related to ratios. It is a crucial topic for UGC NET JRF, as it helps solve various problems involving comparisons and relationships between quantities. This lecture will cover the basic concepts of proportion, types of proportion, methods for solving proportion problems, and strategies to approach related questions in the UGC NET JRF exam, including relevant previous year questions. 1. Definition of proportion. A proportion is an equation that expresses the equality of two ratios. In other words, when two ratios are equal, they form a proportion. For example, if we have two ratios A, B B A, and C D D C, these are said to be in proportion if AB equals CD, BA equals DC. This means the product of the extremes, i.e., A and D. D is equal to the product of the means, i.e., B. B and C. A times D equals B times C. A times D equals B times C. This is known as the cross-product rule of proportions. 2. Types of proportions: direct proportion or directly proportional. Two quantities are said to be directly proportional if one quantity increases, the other also increases, and if one decreases, the other decreases. In a direct proportion, the ratio between the two quantities remains constant. The relationship between the two quantities can be written as xy equals k, where k is a constant y. X equals k, where k is a constant. Example, if a car travels 60 miles in 1 hour, it will travel 120 miles in 2 hours, maintaining a constant ratio of distance to time. Inverse proportion or inversely proportional. Two quantities are said to be inversely proportional if one quantity increases and the other decreases, such that their product remains constant. This can be expressed as x times y equals k, x times y equals k. Example, if 5 workers can complete a task in 20 days, the number of days required for 10 workers to complete the same task would decrease, assuming the product of the number of workers and the number of days remains constant. 3. Solving proportion problems. There are various methods to solve proportion problems, depending on whether the proportion is direct or inverse. Here are the steps involved. Solving direct proportion problems. Step 1. Express the relationship between the two quantities as a ratio. Step 2. Set out the equation by equating the ratio to a constant k. K. Step 3. Solve for the unknown quantity by using cross-multiplication or substitution. Solving inverse proportion problems. Step 1. Express the relationship as x times y equals k. X times y equals k. Step 2. Identify the known quantities and solve for the unknown. 4. Applications of proportion. Proportions are used in various fields to solve problems related to speed, time, and distance. If a person travels 60 miles in 1 hour, the relationship between distance and time is a direct proportion. Work and manpower. If a task requires 5 workers to complete in 10 days, the relationship between the number of workers and the number of days is an inverse proportion. Mixing problems. When 2 or more quantities are mixed in a given ratio, the amount of each component can be determined using proportion. Profit and loss in business. The proportion between cost price, selling price, and profit or loss can be calculated to determine the financial outcome of a business transaction. 5. Previous year UGC net questions on proportion. If 8 men can complete a piece of work in 12 days, how many men will be required to complete the same work in 8 days? A. 10 men. B. 12 men. C. 15 men. D. 18 men. Answer. C. 15 men. Explanation. The number of men and the number of days are inversely proportional. Using the formula men times days equals constant. Men times days equals constant. 8 times 12 equals 15 times 8 rightwards double arrow 96 equals 120. 8 times 12 equals 15 times 8 rightwards double arrow 96 equals 120. UGC NET 2021. The ratio of the number of boys to girls in a class is 5, 7. If there are 48 students in total, how many boys are there? A. 20. B. 21. C. 22. D. 24. Answer. A 20. Explanation. The total number of parts is 5. Plus 7 equals 12. 5 plus 7 equals 12. The number of boys is 5. 12 times 48 equals 2012 times 48 equals 20. UGC NET 2020. In a mixture of 50 liters of milk and water, the ratio of milk to water is 3, 2. How much water is in the mixture? A. 20 liters. B. 25 liters. C. 30 liters. D. 35 liters. Answer. A 20 liters. Explanation. The total parts in the ratio are 3. Plus 2 equals 5. 3 plus 2 equals 5. The amount of water is 2. 5 times 50 equals 2052. Times 50 equals 20 liters. UGC NET 2019. A job can be completed by 5 workers in 12 days. How many workers are needed to complete the same job in 8 days? A. 7 workers. B. 8 workers. C. 10 workers. D. 12 workers. Answer. C. 10 workers. Explanation. The number of workers and the number of days are inversely proportional. Using the formula 5 times 12 equals 10 times 8. 5 times 12 equals 10 times 8. We get the answer. UGC NET 2018. The ratio of the cost price to the selling price of an article is 4, 5. If the selling price is 200 rupees, what is the cost price? A. 150 rupees. B. 160 rupees. C. 180 rupees. D. 190 rupees. Answer. A. 160 rupees. Explanation. The ratio is 4. 554. So the cost price is 4. 5 times 200 equals 16054. Times 200 equals 160. UGC NET 2017. 6. Conclusion. Proportion is a critical concept in mathematical reasoning, with both direct and inverse relationships playing a role in a variety of real-life applications. Understanding the cross-product rule and how to solve proportion problems will help you solve questions efficiently in exams like UGC NET JRF. Regular practice will ensure you can quickly identify and apply the correct methods to solve these types of problems. You said, percentage, ChatGPT said. Mathematical aptitude, percentage, UGC NET JRF Environmental Science Paper I Lecture. Percentages are a crucial concept in mathematical reasoning, as they are frequently used in a wide variety of real-life situations and exam problems. For UGC NET JRF, understanding percentages is essential for solving problems related to comparisons, growth, discounts, profit, and much more. This lecture will cover the fundamental concepts of percentages, methods to solve percentage problems, and strategies to approach related questions in the UGC NET JRF exam, including relevant previous year questions. 1. Definition of percentage. A percentage is a way of expressing a number as a fraction of 100. The word percent means per hundred. Thus, when we say a quantity is a percentage of another quantity, we mean that it represents that part of the total when divided into 100 equal parts. Mathematically, the percentage is expressed as percentage equals part whole times 100. Percentage equals whole part times 100. For example, if 20 students out of 50 passed an exam, the percentage of students who passed is percentage equals 2050 times 100 equals 40%. Percentage equals 50. 20 times 100 equals 40%. 2. Basic formula for percentage to find the percentage of a number. The formula is Percentage of a number equals. Given number times. Percentage 100. Percentage of a number equals 100. Given number times percentage. For example,